Okay, so the topic for this video is about oxidation number. We're determining what is the oxidation number of an element in a compound. It's a fancy term, really, of saying what's the charge of that atom. In fact, here's a definition of oxidation number. Oxidation number is the charge, the charge an atom would have in a molecule or an ionic compound if the atoms were completely transferred. The big thing is it's a charge of the atom. Okay, the first, four words, a charge of the atom. So there are six, I believe six. There's six rules that we're going to use to determine the oxidation number or the charge of an atom. And you're going to have to know these six rules. It's actually not that hard. So you have to know these six rules about how do we determine the charge of an atom. Okay, so the very first rule is what are known as free elements. Elements are uncombined, have an oxidation number of 0. So examples of that: sodium, beryllium, potassium, lead, hydrogen, oxygen, phosphorus. If it's an element in an uncombined, so H2, yes, they're like, but isn't that 2 hydrogens? Yes, it is. Or 2 oxygen here, or 4 phosphoruses here. Yes, they are, but it's just elements by themselves. If it's at H2O, then that's different. That's not a free element. But elements by themselves have an oxidation number of 0. So sodium, beryllium, potassium, lead, hydrogen, oxygen, phosphorus here all have oxidation number 0. Rule number 2 of oxidation numbers, it's pretty much that, unless otherwise stated. For monatomic ions, the oxidation number of an atom, or oxidation number is equal to the charge of the ion. So lithium ion, that's +1, is charged as +1. If it says it's +3, then the charge is +3. If it says the charge is -2, then it's -2. So basically, rule number 1 and 2 basically say, hey, the oxidation number is 0 unless otherwise stated. You can kind of pretty much, that's how I'll kind of summarize rule 1 and 2. The oxidation number of an element is 0 unless it says it's not 0. So if you don't see anything there, it's 0. But if it says it's +3, then it's +3. If it says a -2, then it's -2. So a free element is 0 unless otherwise stated. Okay, next thing, again, I think there's again 6 rules. Third rule, the oxidation number of oxygen is usually -2. Key word here is usually. Most of the time for us, 90 something, I don't want to put a number. So let's say 97%-ish of the time, it's -2. However, an exception to that would be, in this case, H2O2, hydrogen peroxide is the name of this thing. As peroxides, oxygen in that case is -1. It's -1 because hydrogen's charge is +1. 2 +1s, oxygen must be -1, 2 -1s. So in this case, the O2 total charge must be -2, so each oxygen is -1. So oxygen is usually -2, except in this case as peroxide. In that case, hydrogen peroxide. Okay, fourth of, I believe, 6 rules. The oxidation number of hydrogen is +1, except when it's bonded to metals in binary compounds. In these cases, the oxidation number is -1. Okay, so got it, it's +1. It says, except when it's bonded to metals in binary compounds. What does that mean? Hydrogen and a metal only. So there's just binary, meaning 2 things. If you have hydrogen and a metal only, for example, say for instance, you have magnesium MgH2. Magnesium is a metal, hydrogen is a nonmetal. If you have a metal and a nonmetal, the metal and hydrogen, in this case hydrogen, metal and hydrogen only, in that case, oxygen is -1. But that's a metal, whatever the metal is, if it's a metal and hydrogen only. All other cases, hydrogen is +1. Most of the time, it's going to be +1. Okay, again, unless it's of a metal and hydrogen only. You can have 2 hydrogens, you can have 2 metals, or 2 metals total. But it's okay. So, anyways, kind of lost track. So, okay, so hydrogens, yes, +1, except when it's a binary metal. Okay, going on to the next thing. Group 1 metals are +1, group 2 metals are +2, and fluorine is always -1. These are always. Keyword there is always. Group 1 metals, your alkali metals. Group 2 metals, your alkali earth metals. I don't have a periodic table in front of me right now, but group 1, the first column on a periodic table, like sodium, lithium, are group 1 metals. Group 2 metals, like calcium, magnesium. Group 2 metals, always +2. There are no exceptions to that. Fluorine is always -1. Fluorine's a halogen. Many of the halogens are -1, but the only one that always must be, no exception, is fluorine. So underneath fluorine on a periodic table is chlorine, and usually that is -1, but it does not have to be. The only one that is always, no exceptions, is fluorine. Okay, rule 6 of 6. Rule 6 of 6. The sum of the oxidation number of all the atoms in a molecule or ion must equal to the charge of the molecule or ion. Okay, so the total charge must add up to whatever the charge that molecule or ion is. If it doesn't say it has a charge, that's because it adds up to 0. So here's an example. Let's find the oxidation number of all the elements in this. It's called the bicarbonate ion. HCO3, and that's a minus sign. -1, meaning the charge of hydrogen and carbon and the 3 oxygens added up will add up to -1. So if I were to add up all the charges up there, hydrogen, carbon, and 3 oxygens, in this case it will add up to -1. The sum of the oxidation number of all the atoms in a molecular ion is equal to the charge of the molecular ion, which is rule number 6. Okay, so let's get through some of these charges. Let's start an easier one. Hydrogen here. What's the charge of hydrogen in this HCl3 minus? It's right here, rule number 4. Okay, oxidation number of hydrogen is +1. So hydrogen here will be +1. It is not a binary metal. Okay, so hydrogen's +1. What about the charge of oxygen there? Well, if I go back, I'm going to go back for a second. The charge of oxygen is usually -2. So the charge of oxygen is going to be -2. It's not the exception, hydrogen peroxide. So I know in this case, hydrogen's +1 and oxygen's -2. Okay, then I just need to figure out what carbon is. Well, I know the charge of hydrogen. I know the charge of oxygen. I don't know carbon offhand, but I do know hydrogen and carbon, and 3 oxygens will add up to -1. Well, 3 oxygens, 3 times -2, because each oxygen is -2. Plus a hydrogen, which is +1, plus whatever carbon is. That's what this question mark is, but probably should put a C for carbon. Plus the charge of carbon adds up to -1. So what will the charge of carbon be? It's like solving for just basic algebra here. So the charge of carbon in this case is going to have to be +4. So -6 plus 1 plus 4 adds up to -1. The charge of carbon here is +4. So the oxidation number of all the elements in this bicarbonate, HCO3 minus, is hydrogen's +1, carbon's +4, oxygen is -2. Those are the oxidation numbers. Okay, when we write these, we usually write it in the upper right corner. So we always write the charges. If you don't have to write them in, but if you did write them in, we usually write them in the upper right corner of the elements. Okay, here are oxidation number elements in our compounds with a periodic table here. Notice group 1 elements, okay, not hydrogen itself is not technically a metal. Group 1 metals, says here, group 1 metals are always +1. Group 1 metals, lithium, sodium, potassium, rubidium, cesium, always +1. Group 2 metals, go back a second, group 2A metals are always +2. Group 2A metals, +2, +2, +2, +2, +2 for group 2A metals. Other one that's for always, fluorine is always -1. On this table, the one in red are the ones that are most likely, And the ones in black here are what it could possibly be. Okay. So, for instance, carbon is usually +4, but it also could be +2 or -4. Nitrogen's usually +5 or -3, one of those two. But it could be +4, +3, +2, or +1. So these are, the ones that are in black are possible oxidation numbers of an element in nature, and the one in red is just the most likely. Again, notice that group 2A elements, there's only one possibility that is +2, because there's only one group 2 metals. Group 2A metals are always +2, just like fluorine is always -1. No exception to that. Okay, let's find oxidation number of all the elements in the following compounds. Sodium, iodine, that's I for iodine, and 3 oxygens there. I know the charge of sodium. Sodium is a group 1 metal. Group 1 metals are always +1, no exceptions. Oxygen, I also know the charge. Oxygen's usually -2, unless it's hydrogen peroxide, but it's not hydrogen peroxide. So sodium I know, +1. Oxygen I know, -2. So the only one I don't know is iodine. But I know sodium plus +1 plus 3 times -2 plus whatever iodine is adds up to 0. Because I have 3 oxygens, 1 sodium, and whatever iodine is adds up to 0. We could kind of do the math here. That's -6 plus 1, that's -5. -5 plus what equals 0? Okay, that's easy. +5. Iodine's charge in this case, or oxidation number, sometimes I'll say charge, the technical term is oxidation number. Iodine's oxidation number is +5. Okay, next one, IF7. Okay, you're like, wait a second. They're both halogens. They're both -1. Well, they can't both be -1. The reason why they can't both be -1, the charge must add up to 0. Well, one thing I do know is, go back for a second. My face is on top of it. But fluorine is always -1, no exception. Fluorine is always -1, no exception. Knowing that fluorine is always -1, no exception, and I have 7 fluorines, so that's 7 -1s, plus whatever iodine's charge is adds up to 0. Iodine obviously must be the charge of +7. Okay, next one, potassium dichromate. That's what this is called. This is 2 potassiums, 2 chromiums, 7 oxygens. I know oxygen for sure. Oxygen, like right there, is going to be -2. Also know the charge of potassium. Potassium's a group 1 metal. If you look on a periodic table, potassium is group 1 metal. All group 1 metals are always +1, no exceptions. So that means I have 7 -2s because I have 7 oxygens. I have 2 +1s because I have 2 potassiums. 7 -2s plus 2 +1 plus 2 times whatever chromium is adds up to 0. So that's -14 plus 2, that's -12. So 2 times what will equal to, well, just doing the math. I don't really need to do that. I can do this in my head. Okay, so chromium in this case has to be +6. Okay, 6 times 2 is 12. Here's -14, +2. That's -12. -12, +12 adds up to 0. Okay, so that's oxidation numbers. So, just quick summary, going back, there are 6 rules to determine oxidation numbers. I'll go backwards. So, first rule, any element by itself is 0 unless otherwise stated. Oxygen is usually -2, except in the case of peroxide. Hydrogen is usually +1, except as when it's a binary metal. Group 1 metal is always +1, group 2 metal is always +2, and fluorine is always -1. The total charges added up must equal the charge of the molecule or ion. And that's it.